Okay, so we will be discussing stacks today. So I opened this website. It's available on the Brilliant website. They discuss all data structures. So it's always good to read up about it before we start coding. So let's take a look at what they say here. So they claim that stack is an abstract data type that places restrictions on where you can add and remove elements. So the difference between a stack and an array is basically a stack follows a certain constraint, which is a last in, first out element. So if we just open up Paint right here, so a stack is just basically like, if you want to visualize it, it's like a stack of books. And if you want to add the element, you just add on top like this. So you add the first element, the second, the third, and the fourth. And what you can do is you can pop them out. So there are two operations that you can perform on a stack. Is basically you can just put in your elements and you can remove the last element you just put in. So you can't really pop the first element directly. You have to pop the fourth, the third, the second, and the first. So you can push elements and then you can pop them directly off of the stack. And you can there's always one parameter that you need to look at is the top. So you need to always look at the top element to see where it is. So at this instance, the top element is the fourth right here. So you can get the top, which is 4 right here. And if you pop 4, the top will be 3. So you always need to keep track of the top element. Now, the characteristics of a stack, it's the addition or removal of items, and the end is commonly referred as the top, which is discussed right now, and you can just get the bottom if you want. The principle that stack follows is called the LIFO, last in, first out. So it's a stack of books. The last stack we add to the pile must be the one that comes off when we remove the book. Okay, so the minimum required functionalities. So the two basic operations related to the stack is the push and pop. So push, we send the element I. So insert element I at the top of the stack, and we pop, we remove the element at the top of the stack. Now the added functionalities, we can add the size and the peak. So the size, we can get the size of the current stack. Let's say we added 13 elements, so we can ask the class the size of the stack that we have. So we can just say stack.size and we return 13 in that instance, and we can get the peak as well, so the top element inside of the stack. Now let's start coding it in Java now. I just opened IntelliJ right now, and I'm just going to create one thing. So I have a package right here which has main inside of it. So I'm just going to add a new Java class, and I'm gonna call that stack. Okay, so I just added the stack right here. Now we need to keep track of certain things inside of our stack right here. So what we can do is we can first create it as an integer stack, and then we can just incorporate objects into it, because most of the time when you create stacks and when you're working with stacks, you work with them using objects. Sometimes you want to do, most of the time when you're using stacks, you're using mathematical calculations and priority queues. So we need to work with objects directly, but now we're just going to incorporate it as an integer stack. So we're gonna be pushing integers to it. This is the first step. In the next video, we're gonna incorporate objects into it, which is an easy thing to do, but the first thing we want to do is work with integers. So I'm just going to create a private variable. So it's a private, and this is where we're going to hold our stack. So basically, we're going to be pushing inside of an array. This is how we're going to hold our stack. So inside of an array, inside of an integer array to be exact. So we're going to push an integer right here. So it's an array. So that's a first dimensional array. So integer, and we're gonna call that stack. So that's the data structure that's going to hold our integer arrays. So as first stated, we have a top, so we need to keep track of the top element. inside of our stack, so we need to add another private variable, which is going to be our top. So in this case, it's going to be our top. And one thing, most stacks have sizes, so we need to have a size in order to keep track if it's overflowing or not, hence the name of stack overflow. So we need to keep track of the size. We need to first say what size the stack is going to be. So it's going to be a private as well, if I can write private. So private integer, and we're gonna call that size. So that's the size of the stack that we have. Now, whenever we're going to create a new stack object, we're going to call the constructor. So I'm just going to create a public constructor right here. I'm gonna call that stack. So that's how you create a constructor. So this is going to be the default constructor. We don't send any parameters, right? That's why we see an empty parenthesis here, because we're not sending any parameters. So the first thing we're going to do when the user creates a stack from scratch, we're going to have to specify the top. So the top element. So in this case, there isn't any elements inside of our stack as of yet. So it's going to be set to -1, because whenever we're going to push an element into a stack, we're going to increase the number, the top. So in this case, when you push the first element, top is going to be 0 and not -1. We start from -1 because we want the stack to start from index 0 and not from index 1. So top is equal to -1. And we're going to have to set the size. Now the size is going to be 34, so it starts from 0, so it's going to be 35. You can set it as anything you want. You can set it to 100, 200, it doesn't matter. In this case, we're going to have 35 elements. And then we're going to dynamically create the stack. So we're just going to say stack equals to new stack, and actually new integer, excuse me, and then we're going to supply to it the size, right? So we're going to dynamically create our stack. Now this is the constructor where the user doesn't send anything. Now there's a case where the user does send something, and that's going to be the size. So we're going to send the size, and that's where we're going to just basically the same thing. The top is going to be -1, but the size, so the size is going to be equal to the size that the user sent, right? And then we're going to say stack equals to new integer. It's a dynamic array, and we're going to supply to it this dot size. So that's the first thing. So that's the second constructor. Now we're going to have two operations, which is the basic operations that you can perform on a stack. It's a push and a pop. Let's start with a push. So it's going to be public, because we're going to have to talk to it. That's the API. So it's going to be a public void. We're going to call it push. So we push an element. So what we're going to do is we're going to push an integer in this case. Later on, we're going to incorporate objects. So we'll be pushing a certain object and not an integer. So we're going to say public void push integer. We're going to call that element. And now the push, we're going to, once we push an element, we're going to have to start playing around with the top, right? Because the top right here is -1. So we push the first element, it's going to be, the top is going to be at index 0, basically, if you want to think of it in terms of indices. So it's going to say top plus plus. So we're going to increase our top. And then what we're going to do is basically add the element. So we pushed an element, we have to add the actual element into our array, into our stack. So what we're going to do is we're going to say stack of top, right? Because that's the top element, is going to be equal to the element. So we just push the element onto our top of our stack. So that's the push. Now, sometimes this is actually pretty good, but the problem is we're not tracking if the stack is full or not, because if you go above the size, the recommended size, we're going to have an overflow. So we need to check if it's empty or full. So we're going to just write another function right here. So it's going to be a public boolean, and we're going to call it is full. So we're going to basically ask if it's full or not. So I'm just going to write return true here. So the case where it does return true is when it's full, right? So we have to check. So uh, if so when it's full is basically when the length of the stack array is equal to the size, is equal to the so no, basically when the top of the array, so let's say the top is 35 here, right, because they're indices. If it's equal to the stack length, that's where we're going to have an overflow. So basically we're just going to say if top, so if the top element is equal to the stack dot length minus 1, we're going to be returning true. And so I'm just going to put that here, else I'm going to be returning false. So return false. So now we can use this function in order to test that here. So we can say if is full. So if is full, we're not gonna be doing these. So we're just going to negate that. So if it's not full, we're going to just paste that here. So if the stack is not full, we're gonna increment the top and then add the element onto that. And no need to write else. This works perfectly. Now this is the isFull. Now basically that's the push method and that's the isFull method. Now we need to put the other operation, which is pop. So it's going to be a public void pop operation. Actually it's going to return an integer and not a void, because we want to return the last element that we have inside of our stack, the top element. So we're going to return stack, right, the last element of it. So we're going to return top. Okay, now this returns the last element that we have. So let's say the top is the 6th indice, so it's going to be stack of 6, and it's going to return the last element. Now we're going to have to decrement that, so because when you pop an element, you decrease an element from the stack, so it's going to be minus minus here. So what this does right here is basically it's a post increment. So first you're gonna have to return the stack top and then you decrement. So that's how post increment works. If it was pre increment, it would have been differently. You would have decremented top and then you return the stack top, which is not what we want. So that's the pop. And now this is basically the fundamentals of the basic operations of a stack. Now we can add a couple of more things in order to add some functionalities. Now we have what we can do is we can get the size. So we can get the size, so we can write that here. So public integer size, right? So we can get the size of the array, which is basically super easy. We just have to return the stack dot length minus 1. So that's the length that we have. And so that's the size, and we can get the peak element, right? So public integer top, so that's how we get the top. So we're going to return stack, and we're going to return the top of the stack, so right here, and it's going to be minus 1. Now we can return the most bottom element right here, so public integer bottom of the stack. We have the top and we have the bottom, so we're going to say return stack of 0. So the first element, the 0th element, and yep. So these are the basic functionalities of the stack that we have. Now what we can do is we can go to our main function and we can just create a stack object right here. So a stack object, which is basically right here. Is that the right stack? Yep, so that's the stack one. And we're going to create a stack. It's going to be equal new stack, and we're not gonna supply anything to it, so it's gonna go to the default constructor right here. That's gonna set these up. So what we're going to do is we're going to just push to the stack. So stack dot actually I'm using the default one. Stack default one. I don't want to use this one. I want to use my one. So it's going to be a stack. Is that a private public class stack? Oh, they're not in the same package, that's why. So I'm just going to refactor that here. Okay, so now I can talk to stack. So I'm gonna talk to stack right here. So that's the one. So there's a built-in package inside of Java that you can use the stack, but basically we're just looking at the functionalities of a stack. So we're gonna be using our own. So it's gonna be a new stack, and we're gonna resort to a default constructor. Now what we can do is we can push to the stack. So stack dot push. We can push an element to the stack. Let's say we're pushing element 3. So now, so now if we just push another element, let's say, so stack dot push 4, and then we can just take these and just push a couple more. So 4, 5, 6. Now we pushed 4 elements. Now what we can do is we can just say system. We're going to have to print out. So system.out.print line. We're gonna print out the stack dot size. So the size of the stack that we have. We should have 4 now. So I'm just going to run that. So yeah, we have a problem right here because the size, what we did is the size right here. So we're returning the stack.length. We shouldn't do that because the stack.length is 34. Minus 1 is going to bring us at 33. That's why we got the number here. So we shouldn't return the stack.length, but we should return the top. Easy as that. So the top minus 1. So now, if we read on that, we're going to have 0, 1, 2. So nope, we're not going to have a minus 1 here. So we're just going to return the top right here. So we're gonna run that again. So 3. We have 3 elements. Now, if you want to be exact, because 3 because we're starting from 0. Actually, we should have a plus 1, right, to indicate the number of elements that we have. So we have 4 elements right here. We pushed 4. Okay, so if we just add another element right here, let's say another element, let's call it 7, and we just print the size again. We're going to have 4 and 5, so we just increase. Now, what we can do is we can pop, right? So stack dot pop. This should pop the last element of our stack. So if we just ask for the size again, we should get 454. Yep. So we popped the last element. Now we can see which element we popped. So system.out.println. We're gonna just take this. So we're gonna see which element we popped. So we popped the element 7. So we should have just wrote that. Element popped. So this. So element popped 7 and the size is 4. Now, so we got the size and we pushed and we popped. Now we can check the peak element now. So let's check which peak element we have now. System.out.println. So stack dot the top. Let's check which top. We should have 6 now. Let's title it the top of the stack is. We have to concatenate that and let's run that. So the top of the stack is 5. So it should be 6. Let's check here. So good thing we tried that. So the top, this should be just a regular top. Yeah. So the top of the stack is 6. Okay, so this is basically the basic functionalities. We can get the bottom as well. So this should return element 4 now. Actually, no, it should return element 3. And yep, it's full right here. So is full is basically an uh, internal thing, internal function. So we're just going to have to leave it as a private, so we don't talk to it from main. And so basically these are the basic functionalities. We will be covering how to incorporate that as objects of different templates. So we're going to have to create a template that we can send any object E to it. So we can do calculations with it, we can send persons, we can send whatever you can send. So it's not only about primitive data types like integers, doubles, and floats. So after that, we're going to talk about the queue data structure, and then we'll move on to the heap, and maybe we can start doing some algorithms after that. So thank you for watching.